semiconductor design with the focus on network acceleration and a very strong software development background. And today I'd like to present our project for a Sonic Dash accelerator to pass the hero test, able to track millions of connections at hundreds of gigabit per second. So I'm sure I don't need to explain the importance of fast session state management in this round, but just to illustrate the size of the challenge, I'd like to quickly run some numbers. With every packet requiring at least a lookup operation for the Sonic Dash pipeline, let's look at what that means. If we have a 400 gigabit link, we will have to handle anywhere from 33 to 780 million packets per second, resulting in a requirement of tens to hundreds of millions of lookups per second. Next up, insert speed. Now, on a normal day, this will, of course, be much lower, but we want to be able to handle all kinds of traffic, and especially being exposed to the internet, we need to be able to handle overwhelming attacks. So we need to really be able to insert at the same speed, and that includes finding a space, location for each session entry. That brings us to storage capacity. If we want to hold session for each connection for at least a couple of seconds, then that quickly goes into the billions of session entries. So we will need gigabytes of memory. Then no matter how big our storage capacity is, it will eventually run full. So the question is what to do then, because we don't really want to refuse new connections, because that would mean that we've been effectively overwhelmed. So the next best idea might be to drop random entries in our session table. Let's look at what that would result in. If we get flooded with connection requests and have a billion possible entries and create 100 million new entries per second, that gives us a 1 in a billion chance to drop a legitimate connection every 10 to the power of 8 seconds. Now that might not sound too bad, but since those probabilities accumulate over time, in practice, this is pretty bad. So a legitimate download will have a 50% of failing after roughly 7 seconds and a 90% chance of failing after a little more than 20 seconds. And that will for sure result in a lot of unhappy customers. So what we really want to do is replace only entries for sessions that are no longer active, which would allow us to still accept new connections while the active connections would be upheld. But of course, this requires us to be able to know which sessions are currently active and which ones are no longer active. So let's sum that up in a short wish list. We need tens to hundreds of millions of lookups per second, the same number of inserts, billions of capacity of billions of entries in storage capacity, some way to be able to discriminate between active and inactive sessions to find the right space to insert new sessions. And of course, we don't want to do this in software. We want to be able to scale. Let's look at what's currently available on the market.
Quick, do you mind questions in the middle?
Not at all, please.
So I think there's two, maybe, I don't know if they're slightly different or significantly different for the Dash purposes, but you're describing something like a least recently used replacement strategy or approximate least recently used, I imagine.
Mm-hmm.
And another approach is a background task that actively deletes old entries when they reach a certain time threshold since they've been accessed, regardless of whether you need to replace them or not. Just delete them actively, even if even if you're not adding new connection entries. Are you thinking about one that doesn't actively delete old ones and only replaces them when you add new ones, or you're thinking about do you think your approach would apply to either of those strategies?
You're onto it. You're spoilering. But
Okay,
yes,
all right. I'll wait then. Thanks.
all questions are welcome. Thank you. So just quickly looking at storage mediums, we have a lot of fast ones, but only DRAM that offers us the necessary capacity. And of course, none of those have the policy to guarantee not dropping active connections. Let's look at how we manage those mediums. And broadly speaking, we can see that the fast ones don't offer the capacity, and the large ones don't offer the speed. And again, none of them allow us to discriminate. So for that, let's look at policies. That's what you just mentioned, Andy. And here we have the problem that the ones that allow us to quickly insert new entries have a high contention problem, so they don't scale. So summing up, we don't have a solution on the market that checks all the boxes. And that's exactly the problem that our solution tackles. It's an algorithm that we developed that involves some of those steps that Andy just mentioned, and offers very high lookup and insertion rates using DRAM, and also is able to distinguish active from inactive connections, which it does by tracking the age of each connection, and allows the user to configure how many sessions they want to guarantee to hold for how many seconds. Of course, that depends on the total capacity of storage that's allowed. And after that guaranteed retention time expires, the entries are declared evictable, meaning that they're still available if the connection comes back and they have not been evicted meanwhile. Otherwise, if storage space runs out, they are overwritten, which renders the solution to be resilient against overwhelming attacks, and it scales very well. In fact, it scales linearly with the amount of memory channels available. And yeah, it's able to use DRAM by using memory bandwidth extremely efficiently. And all of this is not just a pipe dream. We've really built it. We hadn't built it yet at SmartNIC Summit, but we've built a prototype for a stateful firewall. Important side note, it's a demonstrator of a firewall scenario. So there's no slow path. It's a very simple set of rules. The focus is clearly just on state management. We had a lot of software-based traffic generators bombarding it with a lot of packets that went through the filter, got reflected, and then sent back. And that produced some really nice numbers. In particular, holding 16 billion connections in parallel, or roughly speaking, every device connected to the internet, at an insert speed of 200 million connections per second. Looking back at the wish list we had before, we can see that it checks all the boxes, and looking at what that does in comparison to what's currently on the market, comparing it to the most powerful stateful firewalls that we could find, you can see that it's orders of magnitude above that in terms of new sessions per second and concurrent sessions, again, with the asterisk that it's not a real firewall. So it's just to demonstrate that speed. So why am I presenting it here? Of course, we want to accelerate, use it to accelerate Sonic Dash. In this context, I'm only presenting our idea how to accelerate the fast path for Sonic Dash. So we also have some ideas on how to use smart algorithms to accelerate the slow path, but I left that out of this presentation to keep the focus. And we also ran some numbers, and these are the results that we calculated for the Sonic Dash pipeline for the fast path. What do we want to do now? What are we looking for? We're looking for funding to develop a prototype for the fast path, or ideally also the slow path, but we're also looking for technology partners for knowledge exchange, technology exchange, and also help integrating into the existing ecosystem. And that concludes my presentation. Thank you very much. And Christina, you already had a question. Sorry, I just was so close to the end of the presentation. I just followed through with it.
No,
Please.
that's fine. That's fine. Just because I'm not a dev, although I know a bit about networking. What does not a real firewall mean? Like we're not a real firewall. Like, are you saying you're not a VM using like Palo Alto or Cisco, or like? Can you just explain more what that means to me?
It roughly means no rules. So we just have three rules.
Okay.
These here.
Okay. So TCP, UDP. Okay.
Yeah. And that's
so not even, we don't even have we have like stages of rules inside of Dash, right?
Yeah.
And it's almost like a nested object. Yeah. Okay. Cool. Thank you.
Yeah. So that would be more the focus than on our ideas for the slow path, but also that's something that I'm not too much in the details. We also ran some numbers of that I can quickly teaser here. But yeah.
But I think,
awesome.
I think one way of saying it, this is a hardware technique that could be used for implementing the flow cache portion of Dash. It's not a complete implementation of Dash, but the implementation of the other parts of Dash would be could use this kind of independently.
Exactly.
The other part.
So basically, my goal here is to stress that with this resolving the bottleneck of state management, we could really accelerate the entire pipeline.
Thank you.
Some other follow-up questions. So my belief is, so you're like an intellectual property company, consulting company, and you're willing to talk with either companies that want to make ASICs or FPGA implementations of this to license your technology and use it, and possibly other business requirements as well. And some technical questions. Do you know of any? Have you looked into any differences in DDR5 or HBM memory to see if there's any fundamental limits, or it just applies? It applies to those cases as well.
It does. So I'm not 100% sure if we ran it on DDR5, but the projections are clearly faster, and we ran it on HBM, and we have a speed advantage there at the cost of capacity, of course. So yeah, it doesn't.
How much HBM? How big?
We only have a device with 8 gigabyte of HBM, but it scales with the amount of memory channels. So yeah, it gets faster with more memory.
As does everything. Yep. Yeah. Hey, could you go back to that drawing where it had the hardware?
This one?
There we go. Okay, yeah. Okay. I just wanted to look, so you have your connections. And you're slotting that card into just a server right now?
Yeah, so the solution is really hostless, in fact. So you can see in the setup here, this is the FPGA, and it's not connected to anything. The idea is to fully offload, but we have the possibility to connect via PCI Express. So if you want to run applications on the host, then that's there's also an interface for that.
Ah, okay. Yeah. Thank you. That's pretty cool. Any other questions or comments from anyone else? Mr. Ted?
Yeah, no, interesting. No immediate interest just because we're overwhelmed and busy with our two ASICs. Very interesting. And be happy to exchange emails and stuff, and we could have a private conversation about, I don't know, somebody I know or how to help you. And we can just do that right away. Like, you got my email, tedw@excitelabs.com. So no, this has been interesting. Thank you.
Yeah.
Thank
So
you.
how can the Dash community help you then, do you think, Philip?
Well, as I
Like
said,
creation of tests or oh, go ahead, sorry.
Yeah, we're waiting for the hero test to yeah, run our device against it, but yeah, we're pretty small, so our development capacities of what we can fund ourselves are really limited. So if anybody would be interested in funding us or co-developing a solution, then that would really help.
Okay, all right. And we have Swami on the call. He's from the, who I work with for traffic generation, and they basically help to write the hero test. So if you need connections, I can connect you up. Right.
Absolutely, that would be fantastic.
Yeah. All right. Well, thank you very much. I know shifting. Yeah, thank you. Shifting topics. I know we have Junhua and Xiaofeng over in Microsoft Research China have been continuing to work on the data plane app inside of the behavioral model. So I'm hoping like in a week or two, Riff will be willing to share some outcomes there. If you look at the PRs, you can see where they're making small changes to optimize everything. So, and we've talked about that before, but yeah, that's what we have for this week. Do you guys have anything else you want to talk about, Andy? Any P4 stuff or?
Nothing groundbreaking, but I think I mentioned in the past and emailed Riff the behavioral model, the BMV2, the open source software switch that has been used for some of the reference model testing, was generalized to support if statements and actions that it didn't support earlier that might simplify some of the code that has been written. And then there's some possibility of it supporting loops in the near future, but like that might still be 3 to 6 months away. Also, not clear to me if that would actually make the job any easier for you. But and which PRs were you referring to a moment ago? It was.
Let me check here.
Is this for a potentially non P4 implementation of the reference model? Or am I?
No. Sorry. Actually, I'm going to need your opinion on this one real quick here. But no.
Sure.
So Junhua has been kind of opening and closing these ones in progress where let me see where Xiaofeng's working on the incorrect statement. This one. So updating size subknowledge is not really like earth shaking or groundbreaking or anything, but they're doing these small PRs to fix different things inside of the behavioral model. So that's all I was saying. But I did have a question for you since we're here. I was wondering do you think I could close the one that Maheswari from Intel was working on about the P40 BTK on the horizon? I know we had asked her to basically ensure that this worked,
Yeah, so I didn't, because I commented, I haven't personally tested it.
You have tried it. And I think they said they tried it.
I know they've done some kinds of testing. I don't know if they did that in the context of like, a full dash test or whether it was just like, a more focused unit test of the changes they made. I can't.
Okay, I'll double check with her then, because I mean I know this wasn't the one and only PR. So okay, I'll check with her.
Yep.
So yeah, thanks for coming, guys. That's all I really had for today. Anyone else on the call have anything? Okay. Well, Philip, I do appreciate you. Yeah, thanks, Ted. I do appreciate you coming and showing us the technology you're working on, and I'll make sure that the recording is shared internally. And thanks everyone for coming. Have a good rest of the day.
Thanks, Christina.
Thank you so
Okay,
much.
thank you.
Have a great
Okay.
one.
Thank
Okay,
you for
thanks.
coming. Bye,
Bye.
everyone. Bye-bye.